All right, so where we left off was we were talking about bearings. So we have one more type of word problem. So it says a plane flies 1.3 hours at 110 miles per hour on a bearing of 40 degrees. It then turns and flies 1.5 hours at the same speed on a bearing of 130. So remember that this is just kind of like the first example where we're talking about one type of bearing. So let's go ahead and draw our starting point. So here's our starting point. All right, so I'm going to call this one SP. So it flies at a bearing of 40 degrees, so I know I'm traveling in this direction. So I'm traveling off, and again, here's your 40 degrees right here. And I'm traveling for 1.3 at a speed of 110 miles per hour. So the first thing that I want to do is figure out how far I'm traveling. So if I go 100 miles, all right, in 1 hour, and I'm traveling for 1.3 hours, how far am I going? So 100 and multiply that by 1.3, and we're going to get, oh, not 100, I meant to say, it's 110. Sorry, that was wrong. So let's change that to 110. That's going to give us a different answer. 110 times 1.3. And we're going to travel for 143 miles. So I'm going to put that in red right here. So 143. And then what happens? So again, at this point right here, again, here's due north. I do a bearing of 130 miles per hour, or 130 degrees. So again, if this is 90 degrees, this is 180. 130 is probably somewhere right about there. So again, here's my 130, and I'm traveling for 1.5. So again, I'm going to do this one more time. Basically, multiply 110 by 1.5. So 110 by 1.5, I get 165. 165. And we write that in red, so 165. Boop, boop. And that's as far as I go. So I'm going to call this the end point. So EP. And so now what I want to know is I want to find out how far is the plane from the starting point. So I want to know this guy right here. So in order to do this, right, I need to kind of figure out some stuff, okay? All right, so one of the first things I need to figure out of my figuring out of stuff is I need to make sure that this is a 90-degree triangle. Because right now I don't actually know what this angle actually is, because I don't know if this is 90 degrees. So is this really 50 degrees? I have no idea. But what I do know, all right, so what I do know is this, that if I drop this down a little bit more, I know that this will be 180. So I can do 180 minus 130, and that will give me 50 degrees. So this guy right here is 50. What do I know also? I also know that this line is parallel to this line. Here's my transversal, which means that this angle and this angle are alternate interior angles. So that one has to be 40. So what do I know? 40 and 50. I know that this now is a 90-degree triangle. Okay. I still don't actually know what this angle is, and I actually don't care what this is. So since this is not a perpendicular line, we do not know that this is east-west. All we can do is actually the Pythagorean theorem. So what we're going to do is we're going to say 143 squared plus 165 squared is equal to x squared. So what are these numbers? So 143 squared plus 165 squared is going to give us a 47,674. And then I'm going to take the square root of that. I'm just going to say answer because I don't want to write all that stuff in. And we are going to get about 218.34. So x is about 218.34 miles. So again, we want to be careful unless we see wording that says something like this problem number 1, east-west line. Now I know that this is a 90-degree angle. This one didn't tell us anything with that. So we have to still figure out, is it a 90-degree triangle, and then where to go from there. All right, so let's do one more and a little bit with bearings for both bearings. All right, so here's this problem. So a ship leaves its home port and sails on a bearing north by 30 degrees east. Another ship leaves the same port at the same time and sails on a bearing of south 60 degrees east. If the first ship sails at 26 miles per hour, second ship sails at 30 miles per hour, find the distance between the two ships. Okay, so again, let's draw an axis. So again, everything always starts in northwest. So here's north-south, and again, east-west. So we'll consider this home port. All right, so 30 degrees east would be right about here. So again, this part right here is your 30 degrees. 60 degrees east, so probably somewhere right about there, per se. So again, we're coming up from the south side. So again, this would be your 60 degrees. Okay, here's one boat. Here's one boat. We want to find eventually the distance between these two boats. So I'll put a little X, marks the spot. What do we know? We know that the first ship sails for 26 miles per hour. And, I don't think I added how long. Let's just say, since it's not in here, each ship sails for, let's say, 3 hours. Okay, so we're going to say 26 miles per hour. So if we do 26 by 3, so 18, carry the 1. So 68 would be right here. And then 30 times 3, that would be 90. So 90 miles in 3 hours. So what we want to do is make sure that this is a 90-degree triangle. So if we think about this, again, this has to be 180. So 60 plus 30 gives you 90, which means that this has to be the 90 degrees. So again, this problem is just a Pythagorean theorem problem. So we're just going to say 68 squared plus 90 squared is equal to x squared. So eventually I'm going to take the square root of whatever that gave me. So let's go ahead and check out that number. So 68 squared plus 90 squared, right? 12,724. Take the square root of that answer, and we get it. They're about 112 miles apart. So 112.8 miles apart. So again, a different type of problem to kind of create your right triangle. So again, just try to figure out, draw your north, south, east, west line and try to figure out kind of what's happening in between the two. And again, you're either going to use Pythagorean theorem or you are going to use some sort of trig problem in order to find the distance. So again, different types of applications for the trig problems.